This video will cover how to balance chemical equations. This is a really fundamental part of chemistry because for the rest of the semester, we're going to use chemical equations and the coefficients that we choose need to be right each and every time in order to make sure we're solving for correct values. So, the first thing that's very critical is that we've got to have the correct formulas of all reactants and products. Once we decide that we have the correct formulas, we will not change these formulas. In order to balance things, we will add coefficients, and that would just be a number in front of the chemical formula. And if we don't have anything in front, so if I look down here where aluminum is, there's a blank, and let's say I put a 2 there and a 3 there, then that aluminum, that is assumed to be 1. Okay, although 99% of the time people won't write 1. Okay, and then if we have polyatomic ions that occur on both sides of the reaction, we want to keep them together in our T-chart. And we're going to make a T-chart because we want to be able to have a method that will get us a correct balanced equation for even the really hard equations. Sometimes it's very easy. Sometimes the reaction is actually already balanced and there's not much work to be done. But we want a method that can get us the answer each and every time. And then when we have a combustion reaction, we want to go in the order of Cho. The Cho method is what I'll show you here in a couple of these examples. And then we also want to be able to reduce coefficients if possible. So for example, if we have element X plus element Y forming element A, let's say, and when I go and I balance, I have 2, 2, and then 4. That can be reduced. Each of those can be divisible by 2, so what I really should have is 1, 1, and 2. And again, those ones, whether I have 1 or just blank, those both mean 1. Okay, so let's get started. When we look at this first one, we can classify this reaction, and this is a synthesis reaction. And as I go through and I make a T-chart, I'm going to put R for my reactants. That's these guys, the two things that are reacting, and a P for my products. That's whatever is being formed. Okay, and then I'm going to break it down by element. I have aluminum and I have oxygen. And then I'm going to go through and I'm going to look at this, and I've got 1 aluminum, 2 oxygens. I've got 2 aluminums on the right hand side and then 3 oxygens on the left. And again, these formulas never ever change. Okay, and so one thing as I go through this, I'm going to give you some tips and tricks on what I think is important and kind of some things that I have developed to help me out. And one of them is that if I have a lone element, as I do here with aluminum, I am not worried whatsoever about balancing that. The reason why is however many aluminums I need, I will just put that number right there and then go on my way because then that aluminum is balanced. So the element I should focus on first here would be oxygen. I've got 2 oxygens here and then 3 oxygens on the right hand side. The least common multiple between those two is 6. So essentially I want to get 6 oxygens on each side of my reaction. If I put a 3 here, that will allow me to get 6. Here's how. 3 times the 2 that is already there will give me 6. And then if I put a 2 here, that 2 times the 3 there will also give me 6. And so my oxygens are balanced. However, on the right-hand side with this aluminum oxide solid, putting that 2 there, as a coefficient also affects the aluminum. So what I need to do is I need to make sure I'm keeping track. I actually have 4 aluminums on the right-hand side. So then, like I said earlier, easy peasy to balance the aluminum on the left-hand side, and now I'm balanced. Okay, moving on to this next reaction. I have a combustion reaction. Okay, so when I have combustion, this is the Cho method. This is going to make life a little bit easier. So we have CHO, that's where Cho comes from. And sometimes I'll call it the Cho 1, 2, 3 method. And the reason why is that a combustion reaction always forms CO2 gas and water vapor. And when you count them up on the right-hand side, you always get 1, 2, 3. On the left-hand side, I have 4, then 10, and then 2. The Cho method is good because you want to balance a combustion reaction in the order of C, then H, and then O. So I'm going to go through and I'm going to do that here. If I put a 4 there, that will give me 4 carbons. And now my oxygens will go to 8 plus 1. And so that will be 9. And then my hydrogens, I'll put a 5 here. That will balance my hydrogens, but that also affects my oxygen. So I have 8 oxygens there, plus 5. So 8 plus 5 will be 13. And so I've got to think, what times 2 will be 13 to get my oxygens balanced? And that answer is 6.5. The only thing about that is that it doesn't make a whole lot of sense to have 6.5 oxygen molecules. So what we'll do is we want whole numbers for our coefficients. And so what I'll do is I'll just double everything. So that will go to 2, this will go to 13, this will go to 8, and this will go to 10, and now I'm balanced. Okay, we'll move on to this next example. I've got magnesium hydroxide plus hydrochloric acid in a double replacement reaction. I'm going to go ahead and make my T-chart. And this example is really great because it shows you polyatomic ions. And if I have hydroxide on one side, I need to make sure I have hydroxide on the other side. And if I look here, I don't specifically see hydroxide, but I'm going to show you a little trick. If I've got hydroxide on one side and water on another side, I can essentially write a hydroxide to help me balance. I can turn water into something that some people might call hydrogen hydroxide, which is going to make it a little bit easier for us to balance. So I'm going to go through, I'm going to write magnesium, I'm going to write hydroxide, I'm going to write hydrogen, I'm going to write chlorine. I'm going to do the same for the other side. And it's going to take new chemistry students a little bit of time when it comes to seeing hydroxide and hydrogen, because it feels like you might be counting your hydrogens incorrectly. But let's go through and take our inventory. We've got 1 magnesium, we've got 2 hydroxides here, 1 hydrogen and 1 chlorine. And then 1 magnesium, 2 chlorines, and then 1 hydrogen, and then 1 hydroxide. And so, let me get this correct. What we need to do is we need to focus on getting hydroxide balanced. So what I'll do is I'll put a 2 there. That will make 2 go to hydroxide. And so this changes to 2, but hydrogen is also there, so hydrogen is also affected, and that goes to 2 as well. Now we need to get hydrogen and chlorine balanced. Luckily, they are together, so if I put a 2 there, that actually balances it, and we get this double replacement reaction balance. Okay, now let's look at number 4. Hopefully you can see this as a double replacement reaction. I'm going to go through and make my reactants and my products. And again, we're going to keep our polyatomic ions together. I see carbonate on each side and I see nitrate on each side, so I will make my life a lot easier by just keeping them together. Okay, and so I get a T-chart that looks something like this. I'm going to go through and take my inventory, and I've got 2 nickels, 3 carbonates here, 1 hydrogen, 1 nitrate, and again, I've got oxygens in each of them, but if I balance them by polyatomic ions, I make my life a lot easier. 3 nitrates, 1 carbonate, and then 2 hydrogens. So I don't know the order that would be easiest, so I'm just going to go in the order of my T-chart, and I think that that works out a lot of the time. So what I'm going to do is I'm going to put a 2 there. That makes my nickel at 2, but that also affects nitrate because nitrate is there, and this is where a lot of chemistry students need to take a pause to make sure they get the right amount of nitrates here. I already had 3. If I multiply it by 2, that means I really have 6 nitrates. Okay, and that's important. Okay, so now I'm going to move to carbonate. If I put a 3 here, that will get my carbonate balance exactly what I want, but that also messes with hydrogen. I originally had 2, and if I multiply it by 3, I now have 6. Okay, and then luckily hydrogen and nitrate, they're together on the left-hand side, and I need 6 of them, so I'll put a 6 there, and that goes to 6, and that goes to 6. Some chemistry students will look at this and say 6 times 3 is 18, but I'll say that we only have 1 nitrate. If we really had 3 nitrates, that would look like this, and that's not what we have. Okay, so this reaction is balanced. Let's look at some others. I've got another combustion reaction. I know that that's a combustion reaction because we take a hydrocarbon, react it with oxygen. Sometimes you'll see this with a little triangle above the yield sign indicating that it's probably under heat, and that's a pretty good assumption. And it's going to produce CO2 gas and water vapor, okay, because it's under heat. So this is just our Cho reaction. We're going to get our reactants and our products, and we're going to do Cho. And like I said earlier, we can say Cho 1, 2, 3, because for a combustion reaction, we already know the products are going to be 1, 2, 3 as so. And when I get my count, my carbon is 11, my hydrogen is 22, and what makes this one a little bit tricky is that oxygen is kind of all over the place. And so we want to do oxygen last, crossing our fingers and just hoping that it works out without us having to do too much thinking. And so if I have 4 here and 2 there, that will give me 6 oxygens. And so the Cho method will mean that you do carbon, hydrogen, and then oxygen. And so my carbon will be put on 11 here. That balances my carbon, but that also affects my oxygen. So that gives me 22 plus the 1. That gives me Michael Jordan's number, or 23 oxygens on the product side. I'm going to move to my hydrogens. And if I put an 11 there, and that's just a coincidence that they're the same, that gives me 22 hydrogens. But again, that also affects my oxygen. So I've got 22 plus an 11. That gives me Larry Bird's number for 33. Okay. And now we got to get my oxygens balanced. And this is where it's a little bit tricky. I do not want to mess with my C11H22O4 because that has my carbons and my hydrogens in it, and I've already gotten those guys balanced. So what I would like to do is get my oxygens balanced with just this guy. So what I can think about is that 4 of these are already taken care of, and so I really need to focus on balancing about 29 of them because 4 of them are already taken care of there. So 2 times some number will equal 29, and that number with a little bit of algebra will be 14.5. So I'll put 14.5 there. And you might be saying, Mr. Payne, That is a decimal and we can't have that, and I agree completely. So let's just multiply everything by 2 to get some whole numbers here. So I'll cross out the above reaction to give me some room. And so this 1 will go to a 2, this 14.5 will go to a 29, this 11 will go to a 22, and this 11 will go to a 22, and it's not too common that you see coefficients this large, but here that's what we have, and so that looks pretty good. Let's do a couple other ones. Let's look at number 7. When I look at number 7, this is a synthesis reaction. And when I look at it, I've got my reactants and I've got my products. And I've got nitrogen, oxygen, hydrogen. And some chemistry students will say, but water, should that be HOH? And I would say no, I don't see a hydroxide on this side, so that's not necessary. And then some chemistry students will say there's nitrate there, so should I have really balanced it trying to use nitrate? And I'd say, well, I don't see a nitrate on that side, so no, I think I'm okay. And so I'm going to go ahead and take inventory, see how many I have, understanding that oxygen is in everything. And so I'm kind of going to probably be a little bit annoyed at this one. That would just be my guess, but you know, I don't know. We'll just have to wait and see. So I've got 2, I've got 5 plus 1, so that'd be 6, and then I've got 2 here, so that would be 2. I've got 1, and then 3. So actually, this one doesn't look too bad, because if I put a 2 there, that goes to 2, which is what I want. That guy goes to 6, which is what I want, and H goes to 2. So I think we got pretty lucky here, because normally when it's like that, it's not that easy.